Okay, in this problem we have the Maclaurin series for the function f, given by f of x is the sum from n equals 2 to infinity of negative 1 to the n quantity 2x to the n all over n minus 1 on its interval of convergence. First thing we want to do for this series is to find the interval of convergence for the Maclaurin series and to justify your answer. Here justifying is really just meant to show the work that leads to your answer. So we're going to use the ratio test. Limit as n approaches infinity of the n plus first term, or the absolute value of the n plus first term. So that would be 2x to the n plus 1 over n plus 1 minus 1 is just going to leave n there. Then we'll divide that by, and we'll divide by flipping and multiplying n minus 1 over absolute value of 2x to the nth power. Simplifying, we get the limit as n approaches infinity of n minus 1 over n. We know that that limit is simply 1. Then we have absolute value of 2x to the n plus 1 over 2x quantity to the nth power. N plus 1 minus n is just going to leave 1, and so this limit is simply absolute value of 2x. By the ratio test, this series converges whenever that limit is less than 1. So that will be when x is greater than negative 1/2, less than positive 1/2. Next thing we need to do is to test the endpoints. So when x is equal to negative 1/2, the main thing that'll happen here is in the expression 2x, 2 times negative 1/2 will give us negative 1, and so we'll have the sum from n equals 2 to infinity, negative 1 to the n times negative 1 to the n all over n minus 1. And you can see that the numerator will always be positive in this case. And so we get n equals 2 to infinity of 1 over n minus 1. Writing out a few terms, we'd get 1 over 1 plus 1 over 2 plus 1 over 3. That is the Divergent Harmonic series. And it is also a p-series with p equal to 1, so it diverges. Second, when x is equal to 1/2, what happens there? We get n is equal to 2. The sum from n equals 2 to infinity. In this case, 2 times 1/2 will give us 1. We'll get negative 1 to the n times 1 to the n over n minus 1. And the 1 to the n will always be 1. And so we end up with the sum from n equals 2 to infinity, negative 1 to the n over n minus 1. If you were to write out a few terms of that, you get 1 over 1 minus 1 over 2 plus 1 over 3. And what you end up here with is the convergent alternating harmonic series. And so we can see that f of x converges on x greater than negative 1/2. We don't include the negative 1/2, but we do include the positive 1/2, and that does it for part A of this problem.